Hey y'all, this video is to teach you how to find the average rate of change from several different scenarios. So first of all, average rate of change and slope. They basically mean the same exact thing. So you need to kind of start swapping those out in your brain, as they are two different phrases that mean you're supposed to follow the same steps. So the only difference is slope usually goes with a line. A line has a constant rate of change, which means if you have a linear function, if you have a line, it doesn't matter which 2 points you pick. Any 2 points will give you the same answer. Average rate of change means I have to tell you specifically which 2 points you're supposed to use, because if you use a different pair of points, you might get a different answer. So that's the only difference. Average rate of change, I probably will tell you which 2 points to use, but if it's a line and you can find the slope, I don't have to tell you which points to use, because any pair you pick will give you the same answer. All right, I like to start any slope problem by drawing Mr. Slope Guy. So Mr. Slope Guy is going to help remind you that if your graph is going up, it has a positive rate of change. If your graph is going down, it has a negative rate of change. A vertical line has a slope that is undefined. So that's what his little nose is, that U. And his mouth, a horizontal line, has a slope of 0. All right, and so again, by now you should know that these are your notes, so you can pause, rewatch, but you should copy these down so that you can use these examples to help you with your classwork. All right, so finding the rate of change from a table, we kind of have to analyze both sides and figure out the pattern. So how am I getting from 8 to 10? I'm adding 2. From 10 to 12? Adding 2. 2 to 14, adding 2, and I'm going to do the same thing on the x side. So from -2 to 0 is up 2. That's also up 2. From 2 to 4 is up 2. So the way you find the slope or the rate of change from the table is you have to take the y pattern divided by the x pattern. It has to be y over x. For every single thing that we do with slope and rate of change, it's always your y pattern divided by your x pattern. All right, so the fact that I got the same thing, it's plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. This tells you that if I were to plot these points, it would be a line, because my slope is going to be the same. So I'm going to take my y change, which is up 2, divide that by my x change, which was also up 2. And I'm going to simplify. 2 divided by 2 is 1. So that's the rate of change of this table, 1. And you notice for this example, I didn't tell you which 2 points to use, because if it was the same pattern for all the x's, and it's the same pattern for all the y's, then it wouldn't matter which 2 points you used, you get the same answer. All right, from 2 points, you have 2 options. If you would like, you can just stack your points and do it like a table. So -4, 1, and 2, 4. You can stack them and do it like a table. So 1 plus 3 is 4. And on my x side, if I'm at -4, I'm going to have to add 6 to get to +2. So -4 plus 6. All right, and again, we do the y change divided by the x change. So my y change is up 3. My x change is up 6. And if I reduce that, I can divide both of those numbers by 3, and that would give me 1 over 2. So that's one option. You can just stack them and do it just like a table problem. Or the formula to use is you take the y's, and it doesn't matter which one you start with. I'm going to start with this one because it's bigger. and you subtract the y's on top. And on the bottom, you subtract the x's. And it's just whatever you started with for your y's. You have to start with the same x. So if I had decided to do 1 minus 4 instead, then this would be the x that I started with. So you just have to be consistent. Whichever y you start with, you have to start with the x that's from that same ordered pair. So my bottom, 2 minus negative 4, and that's going to give you the same exact answer because 4 minus 1 is 3, and 2 minus negative 4 is 6. So those are your choices. All right, if I give you a graph, this is a line, so it doesn't matter which 2 points you pick. You could take 2 points and stack them like a table, or you can take 2 points and do y minus y over x minus x. It doesn't matter. You could also make a little slope triangle and do rise over run. It's going to give you the same exact answers. So I'm going to pick these 2 points. So if I were to make a little slope triangle out of this, the up and down is my y. That's the number that always goes on top. The left to right is my x, and that's the number that goes on bottom. So I'm also going to do this way. I'm going to show you that's my first y, that's my second y. That's got to be my first x, and that's my second x. So the other thing, before I even start subtracting, I'm going to look at Mr. Slope Guy. Look at Mr. Slope Guy's eyebrows and tell me, do you think my answer will be positive or negative based on what this line looks like? All right, so my y minus y, 4 minus 2. And I'm going to subtract my x's on the bottom. Negative 3 minus 0. And I'm going to work that out. So 4 minus 2 is 2. Negative 3, take away 0 is negative 3. And I can't reduce that at all because those are both prime numbers. But what we do kind of sometimes do is just put the negative sign out front. You could put the negative sign out front. You could leave it on the 3. You could put it up with the 2. It doesn't matter where you put it. You can either put it up top, out front, or on the bottom. All right, did you say that this would be a negative slope? If you did, great job, because that looks like his eyebrow that's going down. All right, and if you were to make a little slope triangle out of this green side would be 2, and the purple side would be 3 boxes. Down 2 over 3, right? Rise over run, down 2 over 3. All right, remember that you can pause the video and rewatch and copy this as many times as you need to. All right, word problems. After 1 hour, Mike drove 50 miles. By 4 hours, Mike drove 90 miles. Find his rate of change. All right, so if you think about the unit, it kind of helps you figure out which one is supposed to be X and which one is supposed to be Y. Chances are you've been in a car before, and so when you have the speed of a car, the way that you say it is miles per hour. The first one is your Y, the second one is your X, because Y comes first, it goes on top, and that's the way we do rate of change, and that's the way we do slope, is it's the difference in the Y's on top, and then the difference in the X's on bottoms. So you could turn this into a table now that we know which pieces are X's and which pieces are Y's. So 1 hour, 50 miles, 4 hours, 90 miles. Or you could do 90 minus 50 over 4 minus 1. It's going to come out to be the same thing. So that is up 40. And again, I'm choosing to do 90 minus 50 instead of 50 minus 90 just because I know this way will be positive and the other way would be negative. All right, that's up 3, but I could do 4 minus 1. And so you see I get the same thing. The change in y is 40, and the change in x is 3. And I'm going to leave it like that. You could divide it. It would give you a decimal, so you'd kind of have to round it. So I'm just going to leave it as 40 over 3. All right, so this table is not linear. So if you notice in this example, I'm telling you which pairs to use. So find the rate of change from 1990 to the year 2000. And so you can tell, I mean, the years are going up by 5. And again, remember on a table, the one on top is your x and the one on bottom is your y. But look, there's really no pattern to my y's. I mean, that's going up 6. And then that's going up 4, and then it's only going up 3. So in this case, I have to use the 2 that they told me to use, or I'm going to wind up with the wrong answer. So from 1990 to 2000. So basically, you need to ignore everything else that's on this table and do this like a regular table problem, except it's sideways instead of, but I mean, you could take those 2 and you can turn it into a table just like this and do it the same way. All right, so from 1990 to 2000 is up 10. From 18 to 26 is up 8. All right, and if that's hard for you to do, if you don't know how far it is from 18 to 26, you just subtract them. And if you subtract them, it tells you how far apart they are. And then I can just tell this is getting bigger, right? So it's got to be plus instead of minus. All right, so again, I always do the y number over the x number. And 8 over 10 does reduce. I can divide them both by 2. And so that would be 4 over 5. So 4 million people each year. That's the way you would say that out loud. 4 million people each year.